It's a common idea that crypto transactions are, like, totally anonymous.
Right, because of those long wallet addresses, people think it hides everything.
Yeah, but the thing is, on a lot of public blockchains, like Ethereum, your activity, it's maybe not as private as you'd assume.
Exactly. Those addresses give you pseudonymity, sure, but they don't hide what you're doing.
So, like, the amounts, who's involved,
Mm-hmm.
that's often visible.
Often, yeah. It's all in the public ledger, which is, good for making sure things are legit, but
But it's a problem if you want blockchain for more sensitive stuff, like real-world finance.
definitely creates hurdles. Transparency is one thing, but total visibility isn't always what you want.
Okay, let's really get into this then. Today we're doing a deep dive on privacy on Ethereum,
This super important topic right now.
and we're looking at it through a recent interview with Zach Williamson. He's the CEO of Aztec Labs.
Aztec, the layer 2 focused on privacy.
That's the one.
Yeah.
And Zach's background is pretty interesting, not your typical CEO. He's got a PhD in particle physics from Oxford.
Particle physics.
Wow. Spent time at CERN, the big atom smasher place.
Okay, so he's comfortable with complexity.
Seems like it. And he co-invented Pionk.
Oh, Kilom is huge in the zero-knowledge proof world. Really widely used.
So his physics background, thinking about tiny fundamental things, probably influences how he sees blockchain privacy challenges.
You'd think so. And knowing Pilong inside out means he really gets the crypto tools needed for, well, building private systems.
Absolutely. So for you listening, our aim here is to cut through the noise and really understand why privacy is becoming such a big deal for Ethereum.
Yeah, what's driving this push?
We'll look at the core ideas, the solutions being worked on, like Aztec stuff. Think of it as getting you up to speed on a really fundamental shift happening.
A necessary shift, arguably.
We'll cover, what privacy even means here, some common mistakes people make.
Oh, there are definitely misconceptions.
The sort of moral side of it, things like privacy pools, ZKPs, and where this might all be heading on Ethereum.
Sounds good. Zach actually offers a really helpful way to break down privacy itself.
Right. He doesn't see it as just one thing. He talks about 3 pillars, 3 components.
Exactly.
Okay, so the first one he mentions is user privacy. What's the core idea there?
User privacy, that's really about hiding who is doing the transaction.
Keeping the link between the blockchain address and your real-world identity hidden.
Precisely. So the transaction happens, it's recorded, but connecting those dots back to, say, you or a specific company is obscured.
Well, like a digital mask. Okay, then number 2 is data privacy. What's covered there?
Data privacy is about the details of the transaction itself, mainly the amount being sent.
So you might see person A sent something to person B, but you wouldn't know how much.
That's the idea. The value transferred is kept confidential.
Okay, keeping the what secret. And the third one sounds maybe the most complex, code privacy.
Yeah, this one goes deeper. It's about hiding the actual logic that's running on the blockchain.
So for smart contracts, you wouldn't see the underlying code or exactly what computations are happening.
Exactly. The how of the transaction, the specific steps being executed, those remain private too.
Wow. So user, data, and code privacy. Zach calls getting all 3 the holy grail.
Which tells you it's not easy. It's a huge challenge.
But that's the goal for truly private, decentralized systems.
That's the ultimate aim, yeah. Systems that can handle really sensitive stuff securely. He also talks about information asymmetries on-chain.
Information asymmetries.
Yeah.
Okay, translate that for me. Less physics, more blockchain.
Haha, okay. Think about real life where it's important that one person knows something another doesn't. Like
Well,
voting. Zach uses that example. You know who you voted for, right? But nobody else does, ideally. That asymmetry, you knowing, others not, is crucial.
okay, so privacy tech tries to create those controlled secrets on the blockchain.
Exactly. Allowing certain information to be known only by specific parties, just like in the real world for certain interactions.
That makes sense. Okay, moving on. Misconceptions. Zach wants to clear some things up. What's the first big one?
A major one is thinking privacy in crypto just means, like, private token transfers.
Right, like it's only about Monero or Zcash
Yeah.
sending money anonymously.
Yeah, people see it as just that niche. And the second big one is related.
Which is?
Thinking privacy is, like, separate from everything else, separate from DeFi, separate from NFTs.
Like it's this walled garden over here and the rest of crypto's over there.
Exactly. You do DeFi or you do privacy, not both together.
But Zach doesn't see it that way.
Not at all. He thinks that view is just because the tech is still, developing. His prediction is pretty bold, actually.
Go.
He thinks eventually all crypto will be private.
All crypto. Now, okay, why does he think that?
Well, his reasoning is if crypto wants to really break through, handle real-world stuff like Web 2 or TradFi
It
does.
needs the same kind of privacy people expect there.
Exactly. You don't expect your bank balance or every single purchase to be public knowledge. For crypto to compete, it needs to offer that same level of confidentiality.
Hmm. That's a strong argument. If everything becomes private, that changes a lot.
It really does. And that leads into his concept of composable privacy. That's core to what Aztec is building.
Composable privacy. Okay, sounds like Lego, but private. What's the idea?
It's kind of like that. Think about Ethereum smart contracts. You define rules, logic for assets, right?
Yeah, programmable money,
Yes.
programmable assets.
So composable privacy makes private data a core building block in that system. You can create assets and define rules for how they're used with privacy built in from the start.
So it's not just hiding the transfer amount, it's building entire applications with privacy baked into their logic.
Precisely. You could hide who's sending, who's receiving. You could do encrypted checks.
Encrypted checks,
Oh.
like for compliance.
Yeah, imagine needing to prove something, like you're over 18 or not from a sanctioned country, but doing it without revealing your actual age or nationality.
Okay, the system checks the proof, but doesn't see the raw data.
Exactly. It lets developers build really sophisticated things where privacy isn't an afterthought, it's fundamental.
That sounds way beyond just private payments.
Oh, absolutely. It could change how we build online systems, trust, organizations.
Okay, let's talk about the implications then. Why is having these private options on public chains so important, according to Zach?
Well, he starts with the basic nature of blockchains. They're meant to be neutral, permissionless. Anyone can use them, build on them.
Right, that's the core idea.
So given that openness, he argues it's essential that the option for privacy exists within that framework.
It's about choice, not forcing privacy on everyone.
Exactly. And he believes private chains will actually be more valuable and useful because they offer that control. But he adds a really important qualifier: legitimate privacy.
Legitimate privacy.
Yep.
Okay, what does he mean by that specifically? Needs to be unpacked a bit.
For him, it means making sure that when you use privacy tools, you're not accidentally helping out bad actors.
Like making it easier for criminals to hide their activities.
Right. He wants users to feel confident that their own private actions aren't making the ecosystem less safe or enabling illicit use.
He brings up Tornado Cash here, doesn't he? As an example of, well, a challenge.
He does. He points out that tools like Tornado Cash, by mixing everyone's funds together to create privacy.
They increase the anonymity set, the crowd to hide in.
Yes, but that crowd can unfortunately include illicit funds, making it harder to trace them, but also potentially associating legitimate users with them.
So how are things like privacy pools different in their design or intent?
The key difference he highlights is the architecture and maybe the intent around compliance. Privacy pools aim to provide privacy while incorporating ways to, say, prove the source of funds wasn't illicit or meet certain compliance rules without revealing all your transaction details.
Trying to thread that needle between privacy and preventing misuse.
Exactly. It's designed with those legitimate privacy concerns more explicitly in mind, trying to avoid that problem of just expanding the anonymity set for everyone, including bad actors.
That's a critical distinction. Okay, what about censorship resistance? How does privacy intersect with that?
His view is twofold. First, the network itself, the base protocol, must be censorship resistant. No single party should be able to just block valid transactions.
The foundation needs to be neutral.
Right. But second, he thinks smart contract developers should have the freedom to define what counts as a legitimate interaction within their specific application.
Ah, so the L1 stays neutral, but an app built on top can set its own rules.
Pretty much. Privacy is a fundamental right, he argues, letting you represent yourself privately on-chain.
But that right doesn't mean you can force an application to interact with you if you're breaking its rules.
Exactly. You don't have an entitlement to use an app in a way the developers didn't intend or that violates its own stated terms, even if you're doing it privately.
That feels like a practical balance. Okay, he mentioned privacy pools were a good first step. Vitalik Buterin also seems supportive. Let's dig into Zach's view on them.
Yeah, he sees them as valuable, especially given the tech available when they were conceived. He calls the ZK tech back then relatively primitive.
Meaning it limited what they could actually build.
Exactly. It wasn't capable of the kind of complex, programmable privacy they're aiming for now at Aztec.
So privacy pools is a good start, but not the end goal.
That's the gist. Aztec is pushing for full programmability in privacy networks. That's the next leap forward. He uses ZK Passport as an example.
Pass. What is that? Sounds cool.
It is pretty neat. It uses the NFC scanner on your phone.
Like for contactless payments.
Yeah, that tech. And the chip in modern passports. You tap your passport to your phone, and it generates a zero-knowledge proof that you possess a valid passport from a certain country or that you're over a certain age, whatever.
But without revealing your name or passport number or anything else.
Exactly. You choose what specific attribute to prove, and only that proof is generated, not the underlying data.
Wow. Okay, how could that be used in crypto?
Well, think DeFi. Imagine a platform needs to restrict access based on nationality for regulatory reasons.
Instead of uploading documents.
You just provide a ZK proof from your ZK passport. Verifying your nationality is okay for the platform. It's compliant, but totally private for the user, and permissionless.
That is powerful. So that's the kind of thing he means by full programmability being more advanced than current privacy pools.
Yes. ZK Passport shows you can build custom logic around verifying private data for specific applications. Privacy pools using older tech just don't have that flexibility. Programmability unlocks way more use cases.
Makes sense. But getting this stuff mainstream, making private transactions easy for regular people, that sounds hard. What needs to happen on the UX side?
He definitely acknowledges the challenge. He points to PLONK itself as a key design pattern that helped, making ZK proofs more practical.
But it's still complex.
Oh, yeah. Private transactions are just inherently more work than transparent ones. You have to, construct everything privately on your own device before it even hits the chain.
And right now, who feels that pain? The user. The developer.
Both, really. Developers have a much harder time building these apps. It's a steep learning curve.
And for users.
Users often face longer waiting times while those private proofs are generated. Plus, integrating these private apps into the rest of Web3 can be clunky.
Okay, so that's a barrier. What's Aztec's approach to fixing that? How do they make it easier?
They're tackling it on multiple fronts. It's not just one thing.
Like?
While you have the crypto researchers making the core ZK tech better, faster, like improving PLONK.
Okay, faster proofs.
Then you have language designers and tool builders creating things like Noir, their programming language. The goal is to make writing private smart contracts feel more intuitive, less like arcane magic.
Abstracting away the complex math for the developer.
Exactly. And finally, protocol and blockchain designers are building the actual network, the chain, with private state built in from the start, making it easier to manage.
So, splitting the complexity. The crypto nerds handle the deep crypto, the tool builders make it usable, and the protocol people build the right foundation.
That's the idea. Developers shouldn't need a PhD in cryptography to build a cool private app. The tooling is key.
And are they seeing progress?
He sounds optimistic. He mentions their upcoming testnets should really lower the bar for building private apps. We'll have to see, but the goal is definitely simplification.
Okay, that's encouraging. Let's shift focus slightly. Where should this privacy live? Should Ethereum itself try to be private at the base layer, or is it better to leave it to layer 2s like Aztec?
Zach leans heavily towards L2s, or maybe specialized L1s designed for privacy.
Why is that?
Because privacy adds a ton of complexity. He thinks if Ethereum had tried to launch with full privacy built in from day one,
It would have taken way longer.
Yeah.
Been harder to build. Maybe less secure initially.
all of the above, likely. There are trade-offs. Keeping the base layer relatively simple has advantages.
But could L1s like Ethereum add more privacy tech over time?
He thinks they probably will incorporate some privacy features gradually, but a fundamental rewrite for that kind of deep, composable privacy we talked about.
Too hard. Would break too many existing things.
Extremely difficult, yeah. It would likely break backward compatibility, which is a huge deal for a network like Ethereum with so much built on it already.
So for the foreseeable future, the action in serious blockchain privacy is likely going to be on L2s and the apps on top of them.
That seems to be the working assumption, yeah. It feels like the most practical path forward.
We've talked a lot about ZKPs. Are they enough on their own? Or do you need more for real privacy?
He's very clear. ZKPs are powerful, but not the whole story. You absolutely need network-level protections, too.
Like what?
Things like private mempools. The goal is what he calls an end-to-end encrypted blockchain.
End-to-end encrypted, like Signal or WhatsApp, but for blockchain transactions.
Kind of, yeah. The idea is that the sensitive details of your transaction should only be visible to the parties who need to see them for the application to work, not to random observers on the network.
Can you give an example?
Sure. He mentions things like maybe you're paying your mortgage via crypto or you're interacting with a DAO, but you live somewhere that might frown upon that DAO's activities.
You wouldn't want that easily visible.
Exactly. You need privacy at the blockchain level, ZKPs hiding data, and at the network level, preventing snooping on transactions before they're even confirmed.
So it's a multi-layered approach. Privacy isn't just one piece of tech.
Right. He frames it again as a fundamental right, needing protection at all these different stages.
Okay, looking at the ZK space itself, PLShay, Stark, Snarks, it seems kind of fragmented. Lots of different approaches. Is that a good thing or a bad thing right now?
Zach actually sees it as a strength, especially at this stage.
Really? Why? Wouldn't one standard be better?
His argument is that it reflects how early we still are with ZK tech. Nobody has the single perfect answer yet.
So different teams exploring different paths is healthy.
Yeah, because each technology snarks based on Peel-Link or other systems, has different trade-offs. Speed, proof size, security assumptions.
So different tools might be better for different jobs.
Exactly. And having this diversity, this experimentation, is crucial for figuring out what works best long-term. He warns against standardizing too early.
He uses an analogy.
Yeah, the French Minitel system. It was innovative for its time, but France standardized on it, and it arguably held them back when the broader internet came along with a different, more flexible architecture.
Don't lock yourself into something too soon if better things might be around the corner.
Precisely. So for ZK Tech, his view is let the experiments run, let people build. It's too early to pick a single winner.
Makes sense. Okay, one last piece of tech. Fully homomorphic encryption, FHE. Where does that fit in? Is it the next big thing?
Zach acknowledges FHE is potentially incredibly valuable, allows computation on encrypted data, but he adds a big dose of caution. He basically says it needs a few more years in the oven. It's not ready for prime time yet.
So, temper the hype.
Definitely. He advises listening to unbiased experts, not just the hype cycles. The main issue right now is performance.
It's too slow.
The computational overhead is still massive compared to other approaches like ZKPs. So, practical, real-world uses in the near term.
Probably very limited, niche.
He expects them to be extremely limited, yeah. He draws a parallel to where ZK Tech was back in, like, 2010.
Okay, so FHE is maybe where ZKPs were over a decade ago. Promising, but still very early days.
That's the picture he paints. Worth watching, absolutely, but not the immediate solution for broad privacy needs today in the way ZKPs are starting to be.
Got it. Okay, wow, we covered a lot of ground there digging into Zach Williamson's thoughts on Ethereum privacy. Let's try and boil this down. What are the absolute key takeaways for you listening?
I think, first, understand that blockchain privacy isn't just one thing. It's got layers. User, data, code.
Right, the three pillars.
Second, ZK proofs are driving huge progress, especially on layer 2s like Aztec, enabling that programmable privacy.
But the tech alone isn't enough.
No, that's the third point. Making it usable, better developer tools, smoother user experience, that's just as crucial for this stuff to actually take off.
Abstraction of complexity is key.
Exactly. And fourth, the long-term vision seems to be heading towards more privacy across crypto, maybe even becoming the default eventually, though how that plays out is still TBD.
So for you, the listener, hopefully this deep dive makes it clear that privacy isn't some, fringe technical issue. It's becoming absolutely fundamental to building a better, more usable, more resilient blockchain world.
Yeah, it's not just about hiding things. It's about enabling new kinds of interactions, giving users control, building systems that can handle sensitive, real-world use cases.
It really unlocks new potential.
Totally. It's about moving beyond just transparent finance ledgers.
Okay, so here's a final thought to chew on. We've talked about different kinds of privacy, programmable privacy, ZK proofs getting better. Thinking beyond just finance, what other kinds of applications do you think could be totally transformed by truly private blockchains? What new things become possible when privacy is a fundamental building block of our digital interactions?
That's a big question. Lots to consider there.
Definitely something to mull over until our next deep dive.